Hello viewers, I am Ravi Kumar Vemula, a faculty in Computer Science and Engineering Department, Chaitanya Degree University. In this session, we will discuss about the concepts of memory allocation. So, what do you mean by memory and how is memory allocated to the variables or the programs is discussed in this session. Okay, so let us define the word memory. So, what is memory? So we can define the word memory as memory is a physical storage location which is used to store the variables values, or it is a storage location where we load the program for its execution. Coming to types of memory, you speak about primary memory, you talk about secondary memory and whatnot. But making it short, memory is a physical storage location where the data is stored. Fine. Now, when you want to run a program, the operating system, it should assign some memory space to load the program in main memory, right? So when an operating system runs a program, it first loads the program into main memory. And when you say it loads memory, we can use memory to store the machine instructions. We also use memory to store the program data. Right? So program can consist of set of instructions. Once you execute the program, you need to enter the inputs. It will get processed and you get the output. So for that to happen, you need to store memory to handle the program machine instructions. You also need memory to store the program data. So we use memory for both the aspects. Fine then. So going ahead, now let us speak about a typical concept called as segmented memory. Now, what do you mean by the word segmented memory? It is a part of memory which is assigned by the OS to load the program. So, when a program is being executed, a part of the main memory is allocated and that allocation is called as segmented memory. So, keep in mind, for example, when you want to play a game, call it as PUBG, call it as Asphalt 8 or 9, or you want to play a video. When you click on a mobile app, that mobile app will take some time to open, is it not? So what is happening in that time? In that time, the data of that app is being loaded into main memory, into your RAM. So that part of memory where the app is being loaded can be called as segmented memory. Or coming to your programming aspects, when you want to run a C program or a CVP program or a Java program, so that program needs to be allocated some storage space, and that storage space is called as segmented memory. Now, when we have a program, we speak about different types of variables found in that program, and those different types of variables are local variables and global variables. What are local variables? What are global variables? We will see them in detail in the upcoming sessions, but for today, keep in mind that we speak about local variables, we speak about the global variables. And as a part of global variables, when you want to share this global variable to other programs or files, we make them external. So we call them as external variables. Yes or no? So we speak about local variables, we speak about global variables, we also speak about external variables. Apart from these three, we also speak about static variables and we shall speak about dynamic variables. What are static variables? What are dynamic variables? We shall see them in a second. So let's begin with the concept of segmented memory in detail. Now, on the screen you have a diagram. See, this diagram has been called as segmented memory, where in this diagram you find this part of memory is divided into blocks. Block 1, block 2, block 3, block 4, block 5. In this memory, you observe that we have a concept called as stack, we have a concept called as heap. We also have a separate block for the area called as command arguments. We have separate block of data for initialized variables and uninitialized variables. And we have a separate segment called as text. If you watch it carefully, we have a concept called as memory slot for text. In this text, we store the program. So this memory block is basically classified into two types. First one is called as data segment and the second one is called as code segment. As you can, we have data segment here and we have code segment here. Now what is data segment and what is code segment? Code segment is an area of memory where we load the machine instructions. In code segment, we load the machine instructions, and all the remaining space of the main memory of the segmented part is called as data segment, because in data segment we load all the other variables. All the variables that are used as a part of the program, which will be processed as per the instructions written, are kept in this data segment area. So we have code segment, we have data segment. Is it fine? Now, coming to the concept of data segment, you have two important words called as stack and heap. So these two words are used in memory allocation, and we shall see them in detail. Now, what is memory allocation? Memory allocation is a procedure of allocating memory to variables, and that depends on the type of variable used and your requirement. So in general, we use the following two segments for memory allocation. First one is stack memory allocation, second one is heap memory allocation. We use stack memory allocation for auto variables, and we use heap memory allocation for dynamic variables. Now, what is auto variable? If you can recall your concept of storage classes in C language, we have learned four types of storage classes, isn't it? Auto, static, register, external. 90% of the identifiers you use as a part of C program are basically of type auto, isn't it? And the remaining type depends on your application. So 90% of auto variables, 90% of variables of type auto will be allocated in stack memory. Now, what are dynamic variables? Let's see them in detail. Now, before that, let us see that memory allocation is of how many types? Two types. So first one is static allocation, and second one is dynamic allocation. So memory allocation into two parts, static part and dynamic part. Now, what do you mean by the word static allocation? When the compiler knows how much memory is to be allocated to the identifier defined at compile time, then that allocation is called as static memory allocation. So memory allocated at compile time is called as static memory allocation. Now, all these variables which are declared at compile time, which are allocated memory at compile time, will be assigned memory or will be allocated memory in stack segment only. As we have learned a minute ago, saying that we have two types, stack and heap, isn't it? So all the variables which are allocated memory at compile time will be allocated memory in stack segment. And once the memory is allocated to the variables, that memory allocation is fixed. As the memory allocation is done at compile time, the implementation is simple and easy. There are no complications found with this type of allocations. But we have a small disadvantage, and that disadvantage goes like this. Once the memory allocated is fixed, you cannot modify the allocated memory. As you cannot modify the memory being allocated, we have two issues. Issue one is it results in memory insufficiency, or it may result in memory wastage. What do you mean by memory wastage? What do you mean by memory insufficiency? We will give a small example. So let us get to the example next. So in the example, now I declare a variable called as int a. Now what is int a? A is an identifier of type integer. It means that the compiler should assign or allocate 2 or 4 bytes of memory to the identifier A in stack segment. So the compiler knows how much memory is to be allocated to the variable. So this is called as static allocation. Let me give an example. I have an example as int array of 50. It means that the compiler needs to allocate 50 times 4, that is 200 bytes of memory in stack segment at compiler. So before the program is being executed, the compiler knows that it needs to work with 200 bytes of data. So this is called as static memory allocation. And the beauty is, once an array is created, see this array, all the elements, 50 elements are found, and all the elements are identified by common name called as array ARY, and you identify or you access the elements of each block by the index value. So this is how it is allocated. Now what happens here is, in the real-time application, out of 50 variables, you may use only 10 variables or you may use only 5 variables. So if we are using only 10 variables, it means that the memory allocated for the remaining 40 is being wasted. So that results in memory wastage. Yes or no? You allocated memory for 50 variables, isn't it? But out of 50, you are using only 10. It means that 40 element spaces is got wasted. Clear that? Now, for example, in real time, I may need to use 60 variables. But as we have declared only 50 variables, memory is given for 50 only. You cannot expand it to another 10 or another n. So, as the memory is fixed, either it may result in memory wastage or it may result in memory insufficiency. So, these are the disadvantages you have in static memory allocation. Now, moving ahead. Now, let us speak about the concept called as dynamic memory allocation. Now, what is dynamic memory allocation? It is a concept where we allocate memory at runtime or at execution time. It means that the compiler do not know how much memory to be allocated to the defined variables. Clear that? So, and keep in mind, this dynamic memory allocation will allocate memory to the elements in heap segment. So, the memory allocated dynamically is assigned in heap, whereas the memory allocated at compile time is assigned in stack. So, stack segment for static allocation, heap segment for dynamic allocation. Now, the only problem you have to mind, the only issue with this dynamic memory allocation is, in this dynamic memory allocation, the compiler needs to allocate the memory to the variables consecutively. For example, you want to declare an array of size 1000, then it needs to find 1000 into 4000 bytes of memory consecutively. Only then the memory allocation is done, else it is not done. Hence, the implementation is a little complex when compared to static allocation. See, it is clear that in heap segment, the implementation part is a little complex when compared to static allocation. And the beauty of this dynamic memory allocation is memory can be resized, modified. Now, what do you mean by resized? It means that you can either shrink the memory or you can increase the memory based on your applications. So, it does not result in memory wastage or it does not result in memory insufficiency. In this pattern, you can overcome the problems of static memory allocation in dynamic memory allocation. Is it fine? Now, going ahead. Depending on the programming language, dynamic allocation varies. With respect to C language, you can allocate memory dynamically by using few predefined functions to a pointer variable. So, in C language, dynamic memory allocation is done by implementing pointers with the following predefined functions. Now, what are the predefined functions? The first one is malloc, second one is calloc, third one is realloc. Out of these three functions, we use malloc, calloc to allocate memory dynamically, and we use the function realloc to resize the memory allocated. You can shrink the memory or you can expand the memory based on the requirement at runtime by using realloc. And please don't mention it as malloc, calloc. It is really weird. It is malloc, calloc, and realloc. Is that fine? Now, let us see how do you implement the calloc function, malloc function, realloc function. What are the syntaxes in C language? As I told you, you need to implement these predefined functions using a pointer variable. So the first step is declare a pointer variable of some data type. I declared a pointer called as array ARY and some sizes n, n1. Then this is the syntax of malloc. Clear that? See, array is equals to the data type pointer malloc of n times the size of the data type. And if it is calloc, the same as malloc with a small change where it is m comma size of data type. So this is the two different syntax of malloc and calloc. In malloc you have n times size of data type, whereas in calloc you got n into size of data type. Sorry, n comma size of data type. Now what is the difference between malloc and calloc? We will see them in detail. But to make it short, the main point to be discussed is the default value of the variables allocated using malloc is garbage value, but whereas the default values of the variables when worked with calloc is 0 for numeric type and space for character type. This is the basic difference we will see. And the other beauty of calloc is you can declare blocks of data using calloc, whereas in malloc you can declare only one block of data of size n, whereas using calloc you can declare m blocks of data each of size n. So that is how we differentiate malloc and calloc. Now what is realloc? Realloc is found with the same story, the small change. Now I need to modify my space declared initially using a new size. So it is ARY is equals to this data type star realloc, and I am modifying my array using size n1. So it is n1 times size of data type. And if you observe carefully, malloc, calloc, realloc, all these three predefined functions will return a void type pointer. So you need to typecast them into the required data type. Hence we say data type star. So these are the syntaxes of malloc, calloc and realloc. Leave that. Now going ahead, let us see a small example. In the example I took int pointer array n comma n1. Now I am saying array is equals to, as I am using my type as int, it is int star. If it is of type float, float star. If it is of type char, char star. So you have array int pointer malloc of n times size of int, calloc int star, calloc n comma size of int, realloc which is int star realloc array comma n1 into size of int. So this is how we use the functions malloc, calloc and realloc. Is that fine? So in C language we have these predefined functions malloc, calloc and realloc. So what are the basic differences of static allocation and dynamic allocation? Let us see the difference between static part and dynamic part. As the first point says, static allocation is allocated at compile time, dynamic allocation is allocated at runtime. Now coming to the next point, in static allocation it uses stack for managing the memory, it uses heap for managing the memory, and memory remains constant from beginning to end in static allocation, whereas memory can be resized at any point in dynamic allocation. Clear that? So in static allocation we observe that the execution is faster and implementation is easy when compared to dynamic part, whereas in dynamic allocation you observe that the execution is slower when compared to static allocation. The last point is you cannot reuse the memory in static allocation, whereas memory can be reused in dynamic memory allocation. So these are the basic differences of static allocation and dynamic allocation. Fine then, we will see more in the upcoming videos. That's for now. Thank you all.